Hey guys, I'm so sorry I couldn't be here today, but here's the lesson for today, and hopefully this helps so you can pause it and go back over parts if you need to. So we are in Unit 6, and it is day 3. And yesterday we started the process of solving quadratics. So today is going to be solving quadratics continued. All right, so remember yesterday we talked about the 3 different quadratics we were going to look at. We were going to look at factored form, and that's what we did yesterday. And the strategy that we used is set factors equal to 0 and then solve for x. Today's strategy we're going to use is a little bit different because we're not going to work in factor form. We're going to work in vertex form. So that's what we are doing today. And then tomorrow we are going to work with standard form. Okay, so if we have an equation in vertex form, we are going to need a different strategy in order to solve it. So, say for example, we have the equation x minus 3 squared minus 16 equals 0. What is our strategy here going to be to help us solve for x? It's a little bit different than yesterday, but the strategy that we're going to use is this. The first thing we're going to do is we're going to get this number and move it over to the other side. And we do that with addition. We use addition to undo subtraction. So we're going to have x minus 3 squared equals 16. Okay, so why was this a helpful move for us? Well, now what we can do is take the square root of both sides. So we can take the square root of the left side, the square root of x minus 3 squared, and we can take the square root of the right side. So remember, square root and square cancel each other out, and that leaves us with x minus 3 on the left equals, and the square root of 16 is 4. Don't forget your plus or minus. So then how do we finish this up? Well, we have x minus 3, and we undo subtraction with addition. So what we are going to do is x equals 3 plus or minus 4. So remember, plus or minus is a lazy mathematician's way of writing 2 equations in one. This is 3 plus 4, and it's also 3 minus 4. So we're going to have 2 solutions. Let's do 3 plus 4 first. That means x equals 7. And let's do 3 minus 4 next. X equals negative 1. So these are our 2 solutions because they make this original equation true. If you plug them in to our starting equation, you'll find that both of them cause us to get 0. So our strategy here was a little bit different than yesterday, because we're working in vertex form. So our strategy is to move the constant and take the square root of both sides. So strategy, move the constant and square root both sides. All right, so there's a little caveat here. This won't be able to work all the time because sometimes you're going to get functions that are not in vertex form and you are going to want to get them in vertex form, but we can't always do that. It's not always going to come out nice and pretty. So here are the cases when this works. If it's already in vertex form, you're good to go. If it is in factored form, what we did yesterday, don't bother, solve by factoring. And if it is in standard form, then you can get it into you can get it into vertex form. If two things are true. The first thing that needs to be true is that your A term equals 1. And the second thing that needs to be true is that your B term is even. If these things are true, then you can convert to vertex form. So again, if you're starting in vertex form, you're good to go. If you're starting in factored form, this isn't the best strategy, so don't bother, solve by factoring. And if you're starting in standard form, you got to get it to vertex form. When A equals 1 and B is even, then you can convert it to vertex form. So we're going to take a look at some examples of this. All right, so here is an example given to you in standard form. X squared plus 2x minus 3 equals 0. So can we get this into vertex form so we can use today's strategy? Is our A term 1? Yes. Is our B term even? Yes. So we're good to go. So now it's your job to remember from our last unit, how do we convert from standard form to vertex form? Well, the way that we do this is by taking that middle term and cutting it in half. Remember how you made your square? This is your x squared, and then you took your middle term and cut it in half, so you had an x here and an x here, and then you had a little 1 down here. This is completing the square is what we called it to get things into vertex form. So we're going to have this, the length is x plus 1 and the width is x plus 1. So we're going to have x plus 1 squared. And now we have to make it match the original. Right now, our square, as you can see, has 1, 1. And we want it to have negative 3 ones. So how do we get from positive 1 to negative 3? We subtract 4. And now we're happy campers because this is in vertex form and we're ready to go. So what we're going to do first is add 4 to both sides. So x plus 1 squared equals 4. Then we're going to take the square root of both sides. So x plus 1 squared, square root that, and equals 4. And we're going to square root that. So then on our left side, we'll have x plus 1, and on our right side, we'll have plus or minus 2. Now our final step is we have x plus 1, and we want to bring it over here. So what we're going to do is x equals, and we undo addition with subtraction, so minus 1 plus or minus 2. And then we've got our lazy mathematician way of writing things. Negative 1 plus 2 is 1. Negative 1 minus 2 is negative 3. And these are our solutions. All right, we're going to look at 3 more examples. So here's the next one. Example: x squared minus 2a minus 8 equals 0. First thing we're going to do is write this in vertex form. So cut the middle term in half, x minus 1 squared, and then make it match the original. So 1 squared or negative 1 squared is 1, and we want to get 1 to negative 8, so we have to subtract 9 in order to make that happen. Next, we're going to add 9 to both sides, so we're going to have x minus 1 squared equals 9. Then we're going to take the square root of both sides, so we're going to take the square root of x minus 1 squared equals the square root of 9. So the left side square root and square are inverses, so they're gone, and we're going to have x minus 1 equals, and the square root of 9 is plus or minus 3. Then finally, we want to get that 1 to the other side, so we undo subtraction with addition. We do x equals 1 plus or minus 3. So 1 plus 3 is 4, and 1 minus 3 is negative 2. And we're good to go there. So far you may have noticed underneath our radical here, 4 is a perfect square, and here 9 is a perfect square. But remember how you learned what to do if there wasn't a perfect square under a radical. You learned how to simplify it. So we're going to do the same process, but these are going to require the extra step of simplifying. So let's look at example 3. We've got x squared plus 16x plus 10 equals 0. So step 1, we're going to complete the square. Cut the middle term in half. X plus 8 squared, and then we want to get back to 10. Right now, 8 squared is 64, so to get back to 10, we need to subtract 54 equals 0. Now we're going to add 54 to both sides. So x plus 8 squared equals 54. Then we're going to take the square root of both sides. So we're going to do the square root of x plus 8 squared equals the square root of 54. So on our left side, we're going to have x plus 8. But on our right side, 54 is not a perfect square. But you know what to do. You have to make your prime factor tree and factor this. So 54, no matter how it plays out, no matter how you do this, you're going to end up with a 2 and 2 3s. So remember, your factor tree might look different than your neighbor, but you're going to end up, oh wait, sorry, 3 3s. You're going to end up with the same factors. So a 2 and 3 3s. How do you know if you've done this correctly? Well, you can multiply all the factors. 2 times 3 times 3 times 3. Boom, 54. I know I got all the right factors. So now I look for buddies that can come out. 3 is going to come out, and then 2 times 3 is going to stay inside. So we're going to have plus or minus 3 times the square root of 6, because 2 times 3 on the inside is 6. Then finally what we're going to do is we're going to bring that 8 over, and since we're adding 8 here, we're going to subtract to get rid of it. So x equals negative 8 plus or minus 3 radical 6. Now, ladies and gentlemen, over here, you could do 1 plus 3. You could do 1 minus 3, but here you can't. You cannot combine these. They're not like terms. So you're done, and you may leave your answer just like this. Okay, one more example just like this one, and we're going to be done. So last example. X squared minus 4x plus 16 equals 0. First thing we're going to do is we're going to make a square out of this. So we're going to cut the middle term in half, x minus 2 squared. And then 2 squared is 4, but we want 16, so we're going to have to add 12 to get back to 16 equals 0. Then we're going to subtract 12 from both sides. X minus 2 squared equals negative 12. Then we're going to take the square root of both sides. So the square root of the left side is x minus 2 squared and equals the square root of the right side. Okay, so we've got a negative under the radical. What do we do when we have a negative? Remember, something negative that happens is you take out an I. And then we've got 12 here. No matter how you shake it, you are going to get a 2, and a 3. And how can you check that? 2 times 2 times 3 in your calculator. That gives us the 12 we want. So now we're going to have x minus 2 on the right, and we're going to take out 2 because we have a team, and we're also going to take out an I. So we're going to have 2i radical 3. And don't forget your plus or minus out in front. I almost did. That's important. And then finally, we want to get x alone, so we're going to add 2 to both sides. So x equals 2 plus or minus 2i radical 3. And since these are not like terms, you can just circle it. This is your answer. All right, so your homework is going to be, hang on, I'm looking it up. Pages 34 and 35 in your MVP book. And they are on the back shelf under the window if they've not been handed out to you. You're going to do numbers 10 through 15 only. And even though the directions tell you to fill in the different things, it does not tell you to solve by square root. So what I want you to do is, in addition to what it says, I also want you to solve by square root, which is what we did today. So all of those problems, I want you to solve them in the way that you just practiced doing. Okay, good luck. I'll see you tomorrow.